This is question number 16. Here we have to find out the point of maxima of this function. And here there is a condition x is greater than 0. To find out the maxima, find out the point of maxima, our first business is to find out the extreme points of this function. To find out the extreme points of this function, we have to find out the derivative of this function, and we have to so first we have to find out derivative of this function, and we have to equate it with 0. Then we can find out the extreme points of the function. So here f of x is equal to x square into e to the power minus x, and we have to first we will find out the derivative of this function. Okay, so simple derivative product rule will be applied here, and this is derivative, this into derivative of this is 2x, so e to the power x into derivative of x square, it is e to the power x into derivative of x square into x, and this is x square into derivative of this, so derivative of this will be derivative of e to the power x, e to the power x, this is derivative of e to the power minus x, so derivative of e to the power minus x is e to the power minus x. Then by chain rule we will again find out the derivative of minus x, so the derivative of minus x is minus 1, so it is minus. Okay, then this is, you can see, this is e to the power x, e to the power minus x into x, and this is e to the power minus x into x. We can take e to the power minus x into x as common, and in bracket there will be 2 minus x. Okay, so then we will solve this equation, we will find out the value of x. So if we will if we will keep this 2 minus x, so 2 minus x, then e to the power minus x into x will go to this side, and and it will become 0, so x is equal to minus 2. We can say minus x is equal to 2, and this implies x is equal to 2. So the first value of x we got 2, and if we will, in this way, if we will keep x in this side, then we will get x is equal to 0, and if we will keep e to the power minus x, e to the power minus x in this side, then e to the power minus x is equal to 0, and x will be equal to minus infinity. You can see e to the power minus x is equal to 0, so minus x, you can see 0 is equal to e to the power minus x, so log 0, log 0, log 0 is equal to minus x, log 0 is equal to minus x, this implies log 0 is equal to infinity, so minus x is equal to infinity, x is equal to minus infinity. So you can see there are 3 extreme points. First extreme point is 2, second extreme point is 0, and third extreme point is minus infinity. You can see the condition. The condition is x should be greater than 0. X should be greater than 0. You can see this is a 0, and this is a 0, and this is minus infinity. So here we don't have any work with this extreme point and with this extreme point. So the only essential extreme point of us is x is equal to 2. So as this is the only essential extreme point, we can declare directly, if this question is true, if this question is true, then we can declare directly that 2 is the point of maxima of this function. So option B is true. Option B, 2 is at option B, so option B is true. You can also see, we can also check it. Okay, so to check whether x is equal to 2 is a maximum point of maxima or not, we will find out the second order derivative. We will find out the second order derivative. So this is you can see so this is the first order derivative, and we have to find out derivative of this. So derivative of this this is 2x. So we have to find out derivative of this. So what will be the derivative? You can see. Um, so this is e to the power minus x into x into 2 minus x. So e to the power minus x into x. So derivative of 2 minus x, that is minus 1. It is minus 1. Then 2 minus x into derivative of this. 2 minus x into derivative of this. This is e to the power minus x into derivative of x, that is 1. E to the power minus x into 1. Then into uh, e to the power minus x into derivative of x is 1, then plus x into derivative of this, x into derivative of e to the power x, that is e to the power minus x into derivative of minus x, that is minus 1. So x minus x, you can see this is minus x into e to the power minus x. This is simple derivative, and this is an easy matter for you. So however, we obtained the second order derivative of the function, and here we will substitute 2, this is 2, we'll substitute 2 on the place of x. So this is, you can see 2 x to e to the power minus 2 into 2 into this is minus 1, this is minus 1, and you can see 2 minus 2 is equal to 0, so the whole term will become 0. Then at last this is uh, uh, so this is minus 2 by e square, and e is an irrational number. It is a non-terminating. It is a non-terminating and non-recurring decimal number. If you'll accept till 3 decimal places, uh, so it will be 2.718. Okay. So this is 2 by 2.718. So it is a negative number. It is a negative number, and it is less than 0. So as this is less than 0, so you can see the definition. Please see the definition. Maximum, and f is maximum at x is equal to c if f dash c is equal to 0. So by equating the first order derivative with x, we will find out the extreme points, and uh, if f is maximum, when f double dash c is less than 0. When f is maximum when f double dash c is less than 0. You can see this definition. So here this is a negative number, and this is less than 0. So f of x is maximum at x is equal to 2, and the maximum value, if you will substitute 2 on the place of x, you substitute, this is 2 square into e to the power minus 2. So this is 4 by minus 2, 4 by e to the power minus 4 by e to the power plus 2, 4 by e to the power plus 2. So 4 by e to the power plus 2 is the maximum value. Then we will go to question number 17. So it is given the point of continuity of f is defined by f of x is equal to x square minus 1 if x is irrational, and 0 if x is rational. Okay, so we will solve it. It is given f of x is equal to 0. According to the question, f of x, the function of x, is equal to 0 when x is rational. So we can say this is the functional value. This is the functional value of this function. So to find out the points of continuity of the function, to find out the points of continuity of the function f of x, we have to check. We have to check for which value of a, x, limit x tends to a, f of x is equal to 0. We can say if the functional value of a function at a point a is equal to limiting value of that function at that point a, then we can say the function is continuous at the point a. So please see towards the options. So this is root 2 1, this is 1 1 by 2, this is minus 1 by 2 1 by 2, this is minus 1 and 1. You can see, if you will check, limit x tends to, this is plus 1, of this function is equal to 0, and limit x tends to minus 1 of this function is equal to 0. If you'll find out, if you'll find out the limit of this when x tends to 1, then we will get 0, and if you'll find out limit of this when x tends to minus 1, then it is 0. So the limit of this limit of this at x is equal to minus 1 and x is equal to plus 1 equal to 0, and the functional value is also 0. At x, you can say at x is equal to minus 1 and x is equal to 1, the functional value is also 0, because x, it is given the function is 0 when x is rational. You can see minus 1 is a rational number, 1 is also a rational number. So as minus 1 is a rational number and 1 is also a rational number, so the functional value of x will be equal to 0. So here functional value is equal to the limiting value is equal to 0. So we can say the point of continuity of f is minus r minus 1 and 1. The points of continuity of f are minus 1 and 1. Then question number 18, and there is a function, let f is equal to, f of x is equal to x tan inverse 1 by x at x is when x is not equal to 0, and this is 0 when x is equal to 0. Yes, this function. So we have to find out the LHD and RHD of this function. Okay, so this function is continuous. This function is continuous at x is equal to 0, but this is not differentiable at x is equal to 0. Actually, continuity of this function has not been asked in this question. So here here it was written how this function is continuous at x is equal to 0, but in this question it has not been asked about the continuity of this function. It has here it has been asked what is the LHD and what is the RHD of this function at x is equal to 0. So we will find out the first, we will find out, this is, you can see, we will use the formula to find out RHD and LHD. You can see, uh, you can see uh, you can see the formula to find out the RHD, and this is right hand derivative RHD, and this is the formula to find out the left hand derivative. Okay, so we will use this formula to find out the LHD and RHD of this function. Okay, you can see. So So this is arranged at f. This is, we will find out right hand derivative at x is equal to 0. So limit x tends to 0. This is 0 plus h. Here it is plus h. Here it is plus h. It is plus h. But here it is minus h, and this is minus h. Okay. So by applying the formula to find out the right hand derivative of this function, so it will be limit x tends to 0, f of 0 plus h minus f of 0 divided by h, and this is 0 plus h, this is h, and this is 0, and whole divided by h, and f of h, the function is you can see uh, the function is x tan inverse 1 by x when x is not equal to 0. It is 0 when x is equal to 0. uh, so here we will, so this is f of h, this is f of h minus f of 0, this is f of h minus f of 0, and this is h, this is h, and here uh, this is limit h approaches to 0, f of h minus f of 0. So here we have to bring f of h, and here we have to bring f of 0. So f of h minus f of 0, please see f of 0, clearly f of 0 is equal to 0, clearly f of 0 is equal to 0, and f of h is equal to h tan inverse 1 by x. So this is h tan inverse 1 by h. F of h is equal to h tan inverse 1 by h. So this is h tan inverse 1 by h minus f of 0. So f of 0 is equal to 0. This is h tan inverse 1 by h. Yes, this is h and this is h. So h will be cancelled. So limit h approaches to 0. h tan inverse 1 by h divided by h will be cancelled. So this is tan inverse 1 by h, and this is 1 by h is equal to this is h. This is h. When h approaches to 0, and we will find out the value of this. So this will be tan inverse 1 by tan inverse 1 by 0. So this is 0. This is 0. Okay. So tan inverse 1 by 0. So this is tan inverse infinity is equal to pi by 2. Okay. So in this way we'll also find out the left hand derivative of this function, and you can see here it is minus h, here it is minus h. So uh, and this is minus h tan inverse 1 by minus h. So we are getting tan inverse 1 by h. So this is tan inverse minus infinity, and this is minus tan inverse infinity, this is pi by 2, minus pi by 2. So right hand derivative RHD of this function is pi by 2, and LHD of this function is minus pi by 2. You can see LHD you can see the options. So this is option C. So LHD minus pi by 2, LHD pi by 2. So option C is true, and then we'll go to question number 19. Okay, so you can see the question number 19, and this is simply a double integration question. Actually there is a mistake in this question in the question paper of CPET 2021. You can see you can see the options of this question. This is question number 19. This is question number 19, double integration question. The first option is 8, and the second option is 1 by 8, and third option is 1 by 6, and the fourth option is 1 by 7. But none of the options are the answer of this question. So I have solved it. You can see it. The answer is 5. And this is a very simple question of double integration, and no doubt this question is a very simple question, but there are two challenges um, uh, for two reasons. and this question is a little challenging. Okay, so the first reason this question is challenging because it is such a question what doesn't take very less time. Second, it is challenging because one student may commit mistake in addition, subtraction, multiplication, and division while solving this problem. So you have to be careful, and you have to practice well so that you will solve it within very less time, and you will not commit mistake while solving such a problem. So then we'll go to question. You can see it, and I have solved it, so you can see it. um, then question number 20, so it is a triple integration question, and this is also the same same kind of question like question number 9, 10, but this is double integration, this is triple integration. The same two challenges also exist for question number 20. You can win the challenges by practice. I have solved it here, and you can see the solution. Triple integration, and these are the limits. Um, and 24x square y q z dz and dy z dz dy dx dz dy dx. So we'll start from dz with respect to z. So then um, uh, so this is z dz. So the integration will be z square by 2. Okay, z square z square by 2, z square by 2. So the limit are 1 and 0. So 1 square by 2 minus 0 square by 2. This is 1 by 2. So this is 1 by 2, 1 by 2, and this is dy dx, and this is 24, 24. When we integrated it with respect to z and x and y, the x, this is uh, this is we will treat this x term and y term uh, as constants. These came outside. Okay, so this is 1 by 2 dy by dx. Then this is dy, we'll integrate with respect to y, and this is yqy. You can see yq, and the integration of yq is y to the power 4 by 4, y to the power 4 by 4, and the limit is 1 and 0. So this is 1 by 4 divided by 4 minus 0, 1 to the power 4 divided by 4 minus 0 to the power 4 divided by 4. So 1 to the power 4, this is 1, and 1 by 4. So you can see this is 1 by 4, 1 by 4, and you can also see here it is 12, here it was 24, and here it is 1 by 2. So if 24 divided by 2 is equal to 12, so it became a 12, and after integrating it with respect to y, we have got 1 by 4, 1 by 4. So 1 by 4, 4 3s are 12, so it is a 3x square. So 3x square to 1, so 3x square, the integration of this with respect to, now the only variable is x. With respect to x, this is 3x to the power 6 divided by 6. Sorry 6, 3x to the power 3, 3x to the power 3 divided by 3, 3 cancel, then x to the power 3, and limit is 2 and 1. So 2 to the power 3 minus 1 to the power 3, 2 to the power 3 is 8, and 1 to the power 3 is 7. So the answer is 7, and option C is true. Option there is 7 at option C. So option C is true. Thank you so much.